Number 13. All right, we got simplifying to do. Well, let's see. What's the easiest way to do this? The bases are the same. All right, well, these are both doable. So the square root of 64 is 8. Okay, and if you need the chart, use it. All right, the square root of 64 is 8. There you go. The cube root of 64 is 4. All right, again, hold up. Again, the cube root of 64 is 4. So it's really just 8 times 4, which is 32. That is the quickest way to do number 13. Okay, number 14. Now look, these roots are the same. If the roots are the same, I can go ahead and multiply these. So I'm going to get the fourth root of 16. Fourth root of 16 is 2. Okay, I've memorized that by now, but maybe you haven't. So fourth root of 16 is 2. That's where I'm getting that from. All right. Now number 15. Number 15 is a little bit different than any problem that we've had before. And here's what I would recommend. You see the bases are the same. So you feel like we should be able to do something here. But what I recommend is converting this to exponent form first. So if I were you, I would rewrite this. So the cube root of 6 is the same as 6 to the 1/3 power. Okay? The fourth root of 6 is the same thing as 6 to the 1/4 power. So that's what we have here, okay? And all of this is to the 12th power. Now, since the bases are the same, we can add these exponents. Okay, so we are doing 6 to the 1/3 plus 1/4 power to the 12th power. So look, off to the side somewhere, I will do 1/3 plus 1/4. When you're adding fractions, this is when you need like denominators. So I will multiply these by 3, and I will multiply these by 4 in order to get 12 and 12. So I will have 4 over 12, and I will have 3 over 12, which makes 7 over 12. Remember that. So I will have 6 to the 7 over 12 power. Oh, look at that. To the power of 12. Now what you really want to do right now is just cross these 12s out. Boom. So that is going to leave 6 to the 7th power. And that is off the chart. We don't have a 7th power column. So I would just leave it like that. I would accept this as your final answer. All right, on number 16, these both have the same root. If they have the same root, you can do the division. All right, 4 goes into itself once, and 4 goes into 32 8 times. So this is going to become 1 over the cube root of 8. And the cube root of 8 is 2. So this will just be 1 over 2. So that'll be the final answer for number 16. Again, if you haven't memorized this yet, the cube root of 8 is 2. It's on the chart. All right, now number 17. Let's see, all of these have a root of 6. That means I can do the multiplication and then I can do the division. So first I'm going to do this multiplication. So I'm going to have the 6th root of whatever 8 times 16 is. Okay, that's 128. So I have the sixth root of 128. Okay, and that's over the sixth root of 2. So since the roots are the same, I can do this division. So 128 divided by 2 is going to be, so I'm going to have the sixth root of 64. All right, sixth root of 64. All right, now this strikes me as slightly unfair because we don't have a sixth power on this particular chart. Okay, but if we did, it would turn out that 64 would be on it right here. Okay, so it turns out that the sixth root of 64 is 2. And you might have been able to guess it. See how it goes 4. 4 doubled is 8. 8 doubled is 16. 16 doubled is 32. 32 doubled is 64. So I don't know what to tell you about that not being on the chart. But the reality is the sixth root of 64 is 2. Whoops. So that is the final answer. What's up, buddy?
Trevin. What's today's homework here?
All right. Number 18 is sort of a special case. Let's just dive in. Here I see that these roots are the same. So I could definitely multiply these together and get the cube root of 54. Okay? And these roots are the same, so I could definitely multiply these together and get the sixth root of 2. But that's about where it ends. You know, like at this point, these roots are not the same, so I can't divide or anything. Now, one thing that I could do is I could simplify the third root of 54 a little bit more. So let's just look at that separately for a moment. Maybe I'll do it in green because it's separate. Look, remember, if I wanted to do the cube root of 54 and just reduce that, I would be looking at the chart for things that divide evenly into 54. So looking at the power of 3, these are the only two possibilities, and it turns out that 27 divides evenly into 54. So it's right, it's on the chart. So remember how I used to do it? Hold on. So 54 divided by 27, maybe I'll just show you. 54 divided by 27 is 2. So that means I could rewrite 54, all right? So I could do the cube root, and I could put 27 and then times 2. Okay? Now this pink one can be reduced like we used to do. The cube root of 27 is 3, so I can simplify that and bring it out. So I could have 3 times the cube root of 2. Okay, and I got all that from the cube root of 54. So I could do that if I wanted to. So this will now become 3 times the cube root of 2 over the sixth root of 2. Okay, I could do that. Now, what I'm noticing is, now I have 2 bases that are the same. So if the bases are the same, there should be something I should be able to do with these roots. But in order to do it, I really need to change these into exponent form. So I could rewrite this as 3 times, okay? And so this would be 2 to the 1/3 power, all right, cube root. And this one would be 2 to the 1/6 power. Okay? I'm going to need more space. So if I want to do the 2's, that have the same bases, I will subtract these exponents. So I'm just going to carry this up here to the top, okay? So this will be, I still have the 3, so I'll have 3 times 2, all right, but I'm going to subtract these like we would if there was no 3. So this will be 1/3 minus 1/6. Okay, so I guess I should do this off to the side somewhere too. I think I'll do it in purple this time. Okay, so I'm going to do this. So off to the side, I've got 1/3 minus 1/6. To do this with like denominators, I will multiply these by 2. So that is going to give me, that'll give me 2/6 minus 1/6, and that should equal, 2 minus 1 is 1, so that should equal 1/6. Okay, remember that, because that's what's about to happen right now. So that's why I will have 3 times 2 to the 1/6 power. Now, I'm reaching the end of the road, okay? So I'm going to have to talk to my colleagues to decide exactly if we care how we leave this answer, but you know, 3 times 2 to the 1/6 power, or, you know, putting this back into radical form would be 3, the 1/6 power is the 6th root of 2. All right? But these would be the answers. This is the best we can do for number 18. Similarly, looking at number 20, we've got the 5th root of 1,215. As we look at the 5th power column, 1,215 is not here. So we look for the biggest number that might divide evenly into 1,215. So we're going to try either 243 or 32. So let's see, 1,215. Oh, that's in a formula. Hold on. All right, 1,215. Let's try dividing by 243. Oh, okay, that worked right away. So that means this number can be rewritten as 243 times 5. So let's do that. So I can rewrite this as the 5th root of 243 times 5. Now 243 is on the list, so that can be simplified, so I put it in pink. Now the 5th root of 243, 5th root of 243 is 3. So I can replace this with a 3 outside the radical. Now, similarly, looking at number 20, we've got the 5th root of 1,215. As we look at the 5th power column, 1,215 is not here. So we look for the biggest number that might divide evenly into 1,215. So we're going to try either 243 or 32. So let's see, 1,215. Oh, that's in a formula. Hold on. All right, 1,215. Let's try dividing by 243. Oh, okay, that worked right away. So that means this number can be rewritten as 243 times 5. So let's do that. So I can rewrite this as the 5th root of 243 times 5. Now 243 is on the list, so that can be simplified, so I put it in pink. Now the fifth root of 243, is 3. So I can replace this with a 3 outside the radical. Now everything here in blue is going to be left behind. So I will still have the fifth root of 5. So this would be the final answer for number 20. Alright, number 21. Since the roots are the same, we can do the multiplication. So we're going to go ahead and do 18 times 15. Let's move this over. It's distracting. Okay, so 18 times 15 is 270. So what we really have here is the cube root of 270. Now, 270 is not on the list. However, 27 is on the third power list. And you can easily see, because this is a 27 with a 0 behind it, that 270 is 27 times 10. So we can just rewrite this as the cube root of 27 times 10. Okay, the 27 can be simplified. It's on the list, so that's why I write it in pink. Now the cube root of 27 is 3. So we can write the 27 as 3 outside of the radical. That's going to leave everything in blue still there. So I will have the cube root of 10 still inside the radical. So this would be the final answer for number 21. Alright, number 22. We can just multiply the 3 times 5 that's out in front. So we will start off with 15. Now, both of these radicals are fourth root. So since the radicals are the same, we can go ahead and multiply these numbers as well, and that will give us the fourth root of 48. Alright, it's 24 times 2. Okay, so because it's a fourth root, we will be looking at the fourth power column. Notice there is no 48 in the fourth power column. So we're going to have to break this up as something times something. Now 16 is the only thing that has a shot. Excuse me. 16 does divide evenly into 48. Specifically, 48 is 3 times 16. So I can rewrite 48 as 16, that's on the list, times 3. I wrote the 16 in pink because that can be simplified. The fourth root of 16 is 2. So I can replace that 16 with a 2 on the outside of the radical. Now everything here in blue is going to be left inside the radical. So I'll have the fourth root of 3 still. And that 15 is still out in front, and just understand that it is multiplying. So if I do 15 times 2, I get 30. So my final answer will be 30 times the fourth root of 3. Alright, on number 23, these roots are not the same. I've got the cube root and I've got the second root. So I cannot multiply these together. What I can do is I can do the square root of 25. And the square root of 25 is simply 5. So I can just put 5 times the cube root of 25. And you know what? I would accept this as the final answer. There is one other thing I could have done just for the sake of being thorough and complete. So this is done. I'm just showing you something else you could have done if you had wanted to. Because these are both 25s, that means the bases are the same. So I could have rewritten these in exponent form. So I could have had 25 to the 1/2 power times 25 to the 1/3 power. Okay, so I could put these together by adding these powers. So I could have had 25, and then I could have added 1/2 plus 1/3. Now remember, for this type of a problem, you need like denominators. So like multiply these by 2, multiply these by 3. Okay, so that's going to give me so what do we got? So that's going to be 3/6 plus 2/6. Well, 3/6 plus 2/6 is 5/6. So I could have written 25 to the 5/6. Now, since we started off in radical form, we really need to write our final answer in radical form. So in radical form, this would be, this is the power and this is the root. So this would be the 6th root of 25 to the 5th power. Okay, so both of these are equivalent, but you can see that this one isn't any more simplified than this one. So so you really could just have left it in the first place. Alright, moving on to number 24. Okay, to do a problem like this, I would definitely rewrite this in exponent form. But just remember, the original problem is in radical form. So in the end, we should make sure the answer is in radical form, unless it just turns out to be a whole number. Okay, so in exponent form, this would be 7 to the 1/3 power times 7 to the 1/4 power. Okay, so that's all going on inside the parentheses, which are to the 24th power. Now, when we multiply numbers with exponents, we add the exponents and keep the same number. So look, off to the side somewhere, I'm going to do this. Alright, so we're talking about 1/3 plus 1/4. Okay, so we will multiply this one by 4 to make 12, and we will multiply this one by 3 to make 12. So that is why we will have 4/12 plus 3/12, which is 7/12. Okay, so that's what is going to happen to these exponents. So that is why I will have 7 to the 7/12 power. Now this entire thing is being raised to the 24th power. Now you guys tend to multiply the 7 times the 24 and get whatever that number is. This is what you guys usually do. You go 7 times 24. Alright, that's 168. So you guys usually go, okay, that would be 7 to the 168 power, and of course 12 times 1 is 12. And then you hope to divide this in, okay, and it will go. So 168 divided by 12 is 14. So then you would get your 7 to the 14th power. Okay, and that's just going to be the final answer. But if you can get comfortable with the following small change to that process, it will save you some time in the future. When I'm at this level, when I see things that will divide in while the numbers are small, it's quicker to do it this way. I see that 12 goes into 24 twice. So I just do that. And then I know that 7 times 2 is 14. So I would immediately get the 14, and I skip this middle step. Alright, so it's quicker if you can understand it. Try it out. Alright, so that was number 24.